Let's go. This video is about series resistance imaging using EL images. First, we import some EL images and one background image. Okay, so we have one low current image, one high current image. The low current image is done at 10% ISC, which is the short circuit current. The high current image is done at 100% relative to ISC, and then we have a background image. First, let's get rid of the background. In the last video I showed you how to remove all these things with a camera calibration file and this tool called Correct Camera. He will just do it manually, so you see that there are also other ways you can do it. So let's remove the background layer 2 from display layer 0. So minus equal display layer 2. Okay, and the same thing, let's do this for the second image. Good. Now both images are background corrected. You see, everything starts basically at 0, so we don't need the background image anymore. Let's click on it and remove. Good. Now we need the button series resistance series resistance map. Technically, and if you have the right file format, you can directly execute it without doing everything extra. Because in this tool, parameters like exposure time, voltage, current and temperature can be read from the file name. If your file name doesn't comply, you can also set all these parameters manually. So let's do this quickly. The first image has an exposure time, as we see, of 51 seconds, a voltage of around about 33 volt, a current of 0.810 and some degrees. The second image has an exposure time of 19.2, a voltage of 39.5 and a current of 8.1, let's say 6. Okay, let's activate. It now asks us to define a grid first, which is needed to measure the highest spot in every cell according to the Potthoff method. What's done in background, actually, you can read in my thesis at some point in the future. So let's do some grid definition quickly. This can be also done automated with the tool perspective correction. But here, let's just do it by hand. Okay, as you see, there are still some vignetting going on, so that's why the intensities in the middle are brighter, and there's also some lens distortion. Otherwise, the grid would actually align properly. So these things would of course needed to be corrected in prior before you can do series resistance mapping. Here for this example, let's just forget about it for the moment. Okay, everything is set. We have the two images, we have our grid, all the parameters are defined. We click on activate, and in result we get a series resistance map. Let's give it some nice color from, as you see, 0 to like 8 ohm. Okay, we get the local dark saturation current, some small number in ampere, and we get the local cell operating voltages. As you see here, the voltages are highest in the cell middle and the device middle. This is because of the non-correction of vignetting. So please, before you calculate series resistance, make sure that all imaging distortions are removed using the tool Camera Correct and Perspective Correction. Here you go, series resistance mapping made easy by dataArtist. I hope you enjoyed it. Bye bye.